guys, my name is Mr. Luwasi, a 60th year medical student, and today we'll go through solving forces on an inclined plane. So to do so, we're going to solve a question, and the question reads: when a force of 450 newtons pushes on a 20 kg box, as shown below, the acceleration of the box up the incline is 0.70 meters per second squared. Find the coefficient of sliding friction between the box and the incline. Okay, so we've been given this is the force of 450 newtons. We've been told that the weight of this box is 20 kgs. The angle here on an inclined plane is 45 degrees. So the first thing to do, you collect the data. Okay, so you say the data, what we have the force of 450 newtons. Okay, we have the mass, which is 20 kgs. We have the angle, which is theta, of 45 degrees. We have the acceleration in the x-axis, which is 0.70 meters per second squared. Okay, we have the gravity. We know that acceleration due to gravity is 9.8 meters per second squared. Now, what have we been told to find? So we've been told to find the coefficient of sliding friction. Okay, this is the frictional force which is acting on a moving object. So this is also mu k, which is kinetic coefficient of friction, which we don't know. Okay, so now we've collected the data. So the second step, we are going to we have to show all the forces acting on the inclined plane. Okay, to do so, I'm going to draw this here. Okay, we have our angle. Okay, we have our angle, which is 45. Okay, we have our box. We have a force, this force acting on this box. Okay, so now we have forces in the x and the y direction. So the force acting vertically downward here is the weight. Okay, so we have the weight, which is mg, it's acting downward. We have the force which is acting upward, or the force which is acting perpendicular to the inclined plane. So this is the normal force. So the normal force is N. Okay? So, as you can see, this force here which is pushing this is not the force which is pushing the box. So this force is pushing the box at an angle. So there is part of this force which is pushing the box in the x direction, and we have another force which is pushing it in the y direction. So we have a force, a component of this force. It is pushing the box in the x direction, and we have another force, a component of this force, which is pushing in the y direction. Okay, then we have the force now which is opposing the motion of this box, which is the frictional force. So the frictional force is acting in the opposite direction. And as you can see here, the weight, so the weight is not acting straight downward. So it's acting at an angle. So we need to resolve it into x and y component. So we have this component, okay, acting this side, and we have another component of the weight acting this direction. So now what you have to note is that the angle here is the same as the angle here, and this same angle which is here is the same as the angle which is there. Okay, so now let's resolve this force and the weight into x and y component. How do we do so? So to do this, we know that we have a triangle here, a right-sided triangle. We have a right-sided triangle. So now, this force which is here, it is the adjacent. This angle, this is the adjacent, this is the opposite, and this is the hypotenuse. So to find this side here, it is, I'm going to name this side as y. To find this, we know that it's going to be the weight cos the angle. This one here, it's going to be mg, I'm going to name it as x, mg sine theta, okay, which is the same as this one I've shown here. To resolve this one, this is going to be the force cos theta, this is going to be the force sine theta. Now, having done this, having resolved all the forces acting on this box, we need to find the summation of forces in the x-axis and the summation of forces in the y-axis. So, okay, so this is the frictional force. The summation of forces in the x-axis is equal to mass times the acceleration in the x-axis. Okay, now, what forces are acting in the x-axis? So we have a force which is pushing the box forward and the opposing forces. So the force which is pushing the box forward, we have F cos theta. We have two forces which are opposing this force, which is the mg sine theta and the frictional force. So minus mg sine theta. So as you can see, I'm subtracting, not adding. These are opposing forces. Minus friction is equal to ma x. Okay, so now for the summation of forces in the y-axis, it just be the same, ma y. But now this box is not moving up and down. Therefore, the summation of forces in the y-axis will be equal to 0. Summation of forces in the y-axis is equal to 0. We have one positive force, which is the normal force. We have, which is the normal force, which is N, minus, we have two forces acting downwards, which is the mg cos theta, mg cos theta, and we have the mg cos theta and the f sin theta, which is equal to 0. Okay, so now we have the two equations. So we know that we have to find the coefficient of sliding friction. So this will be equal to f cos theta minus mg sin theta, and we know that friction is mu k times the normal force is equal to ma x. Okay, so here we know that we can make the mu k, we have to make the mu k the subject of the formula. We will have f cos theta minus mg sin theta, okay, minus the max cos this side, max is equal to mu k, the normal force. So we divide by the normal force, we divide everything by the normal force. Okay, this one and this one goes. This implies that the mu, which is the kinetic coefficient of friction, will be equal to the force cos theta minus mg sin theta minus max over the normal force. Okay, so we can find the normal force. So we know that normal force will be equal to this one goes this side, mg cos theta plus the force sine theta. Okay, so this is equal to. Now we have our data here. The force is 450 newtons. I mean the mass is 20 kgs, sorry. We have the mass which is 20. We have the gravity which is 9.8 cos the angle is 45 plus the force it's 450 newtons. Okay, sine the angle is 45. Okay, so this will be equal to, okay, let me just calculate my calculator. 20 times 9.8 cos theta which is cos 45, okay, plus 450 we're multiplying by sine 45. Okay, so we have 456.8 newtons. So this is the normal force. We have the normal force. We can also make substitutions this side. So mu k is equal to the force is 450 cos 45 minus the weight, the mass which is 20, the gravity is 9.8 sine 45 minus the mass is 20, the acceleration in the x direction is 0.70, everything divided by 456.8. This is equal to, okay, so we have 450 cos 45, okay, minus 20 multiplied by 9.8, okay, sine 45, okay, minus 20 multiplied by 0.70. Okay. This will be equal to 165.6. So we're going to divide this by 456.8. Okay. Okay. So therefore, the coefficient of sliding friction is equal to 165.6 divided by 456.8. Okay, this will be equal to 0.363.